school seniors in the room. So today we're going to go over a lot of information about environmental engineering. We have the pleasure of having Dr. Trevor Boyer with us. He is the program chair for environmental engineering, and he will be leading our presentation today. My name is Sharon Torres. I'm with the outreach and recruitment team at Fulton Schools of Engineering. So if you have any questions during the presentation, please feel free to type it in the Q&A box, and we will at some point pause and address those questions. If it's a question that I can address directly, I might reply to you directly in the Q&A. But if you think of something, please feel free to shoot us a message in the Q&A. The chat feature is disabled, so you'll be able to communicate with us through the Q&A. For those of you who just joined us, welcome. And this presentation will be led by Dr. Trevor Boyer. So without further ado, I'm going to turn it over to Dr. Boyer.
Great, thanks, Sharon. And yes, please, make this session interactive. Post questions there for Sharon and myself. I can answer things specific to environmental engineering, and I'm sure Sharon can answer kind of broader, application questions. So please put those in there. Let me go to presentation mode here. So what I wanted to do was kind of get you excited about environmental engineering as a major and just give you some background on it. And in particular, what I wanted to do was talk about, big challenges that we're facing in society and how I see environmental engineers playing a key role in developing solutions, particularly sustainable solutions to those problems. And so in terms of how I've organized these slides, maybe about 20 minutes. First is sort of talking about these grand challenges. What are they? What are these big problems that we need to work on as engineers, scientists, there's other majors that can address these. What kind of, so not only what are the challenges, but then what kind of person is needed? I think that's actually a more interesting question. So we can explore that a bit. What kind of person is needed? And then finally, what is environmental engineering? Some of you may have an idea. Some of you may just sort of see the words environmental and engineering and sort of have mashed them together, some kind of maybe activism plus math or activism plus chemistry. And so we can see what that is. We can see kind of what the curriculum consists of, career choices, and what kind of impact you might be able to have in your career. All right, so here are some grand challenges facing society. And I'll elaborate on each of these, but just to lay them out there. The first is sustainably supplying food, water, and energy. So those are really, basic things that we need: clean water, nutritious food, energy that doesn't pollute. So how are they related, and how do we get them sustainably? We'll talk about. Curbing climate change and adapting to its impacts. Climate change is a real challenge because its impacts are varied across the US and across the world, and they vary in timescales as well. So how do we adapt to them? Designing a future without pollution and waste sounds a bit lofty, but it is something that we could work towards. And really closely related to that would be then designing or creating efficient, healthy, and resilient cities. We can talk about what that means. And then finally, to accomplish all of these things, we really need to be able to, learn how to work together, process information, make decisions, and have those decisions lead to actions. And that in and of itself is actually a pretty significant challenge. So let's talk a little bit more about sustainably supply food, water, and energy. And so why are these even lumped together? Well, it turns out that they're all related. And so I do research on water treatment. And what I can tell you is that, we can take pretty much any source of water and make it clean. One of the key ingredients is electricity. A lot of technologies that clean water require a lot of electricity. And so then therefore, to have clean water, we're very dependent on energy, okay? And so energy, can come from renewable and non-renewable sources. And really the challenge there is the pollution that's created. And in some cases, the pollution that's created is water pollution, right? So we've created energy to clean water, but at the same time, we've, say, polluted water somewhere else. And then both of these now are going to be needed to make food. Water in particular is needed to grow the food, but the energy comes in many ways for the food. It's, transporting the food at various stages the farm equipment that grows and harvests the food, but then we have the whole food supply chain of animals and processing. And so we can see how they're all related. And so one is very much dependent on the other. And, whether we decide to go with sort of a clean source or a polluting source to obtain energy, then kind of trickles down and impacts the water and the food. With respect to climate change, as I mentioned, it's one of the real challenges, I think, is that it's not a sort of single impact, right? In some places it's drought, in other places it's, wildfires, it's floods. But what they all are kind of extreme events that deviate from sort of historical trends. And they deviate both in severity and in frequency. So, scientists have shown through data collection that these events are happening, more often, and their impacts are much more severe. So how do we adapt, and how do we possibly, mitigate or prevent them? All right, so designing a future without pollution and waste. And so one of the easiest ways to sort of see that we're not doing this is if you take out your trash each week or each day, right? We generate a lot of solid waste. Using water generates, polluted water, right? And then all the activities we do at home or at work generate waste. And many of those products we used, generated sort of pollution in their manufacturing process. And so I, by no means, I'm a very practical person. I mean, that's one of the things I like about engineering, is that it's very much a practical degree and a practical career. So I'm not advocating some sort of society without material products, but I am in favor of us thinking about how those material products are created, and looking into the chemistry and the microbiology and figuring out, can we do those in sort of cleaner ways? And so there's different movements. One of them is called green chemistry and green engineering, that tries to look at the process and see, can we do this with, different chemical inputs that are safer? Can we do this at lower temperatures where we require less electricity for heating? Can we reuse something? So part of it goes into, and you will learn this if you become an engineer. It's easier to improve a process if you look at it in sort of its early stages of development. It's much harder to improve a process once something is already built. If a product or a process is already built and you want to make it better, well, you're really limited in what you can do. You can only make some minor adjustments. However, if you're able to look at something from the very beginning and make some decisions early on, you can have a huge impact. And that can then translate to, for example, less pollution and less waste. And so this refers maybe more to sort of like the product level. If we're able to apply those same ideas at the sort of city level, then we get this, sort of utopian view here of an efficient, healthy, resilient city where, maybe most of the electricity comes from solar or wind. Water is, say, recycled and used for various purposes, and maybe rainwater is collected for, places that get rain. With respect to sort of recycling, we can reuse many products, we can recover energy from products, we can recover other materials from products. So again, it's taking this approach where maybe you're looking at an individual product and how can you kind of improve it, and now taking a bigger view of a city, and how can we think about the water supply and energy and waste management of the city. And then finally, as I've mentioned, to really turn all these ideas into actions, you need a diverse team. You need a team that's able to sort of sort through all the information that's out there, and and understand that not all sort of information is created equally. And as a scientist or an engineer, we know that there are sort of limitations to the data we collect and generate. The problem is we can never be, say, 100% sure about something. That's kind of the basis of science, but we can be much more certain about some pieces of information than others. And so it's important that we recognize that some information is more accurate than others. We bring that together with diverse teams, and we're able to then make decisions and actions. So those are the challenges. All right, pretty lofty. I think I meet lots of students. I meet freshmen when I teach them in ASU 101. I, work with juniors and seniors and grad students. And so I'd say, many students are idealistic, which is great, and they would find one or more of these things very motivational. These are things that they would like to work on, make the world a better place. And so the question is, what kind of person can do that? And so one sort of model for a person is called a T-shaped person. And a T-shaped person is not myself, Trevor, but a T-shaped person is someone who really has some depth of knowledge in a topic. So that topic could be environmental engineering, but then they're also just very knowledgeable in sort of all things. And you've maybe know of someone like this who, like, they're really sharp on one thing, but then they just seem to know a little bit about everything. It's not an easy thing to accomplish, but it is sort of a model that you could work towards. And so, for example, if you come to ASU, you select a major like environmental engineering, you commit yourself to really understanding the fundamentals of that. And then you choose wisely in things like your general studies electives and your technical electives to help sort of round out your knowledge. The way that ends up, looking is you're then sort of constantly in balance of, making sure that you sort of know all you can about, environmental engineering from, say, a, bachelor's degree perspective, but that you think about, well, what are the areas that environmental engineering touches on? Well, environmental engineering is very much driven by regulations. And so you may need to know some things about law and policy. Um, a newer area of environmental engineering is sort of all the data that's available to us because of advances in computer science. And so wanting to know some things about computer science or data science, and some of the things we do really impact society directly. So understanding humanities and communication. So that's kind of how you would think through this process. A more sort of tangible view is sort of all the courses you could possibly take. And so I've listed here a range of courses. At the top, it's kind of more freshman type sciences, chemistry, physics, biology. Then it moves into things we call like some of the sort of engineering sciences, like environmental chemistry or fluid mechanics. And then finally into the engineering courses. So I put a few highlights here. So yeah, so up at the top, we have, calculus, chemistry, physics, biology. Then we have some of the engineering sciences in the middle. And then finally, we get into the design courses, being an actual engineer, designing water and wastewater plants, designing remediation systems, water resources engineering. And so this starts to kind of hint at the sort of balance between breadth of subjects and then depth of knowledge in environmental engineering. And so at this point, we've talked about the grand challenges facing society. I mean, they're not trivial. They are going to require some real thought, both in sort of the fundamentals, but also some real creative ideas as well. I don't want people to think that there's not the opportunity here to be creative. So there are major challenges. And so we need kind of well-prepared people to tackle those challenges. And one way to be sort of a well-prepared person is to be this T-shaped person, to develop expertise in a subject, but then also, breadth of knowledge. And you could swap out, I'm not saying that environmental engineering is the only place to get depth. There are other engineering majors, there's science majors, it could be a journalist and communicate all this information to people. And then for breadth of knowledge, you may need to take, some science and engineering classes in order to be able to, write accurate stories about science and technology. So, don't think that this T-shaped person is only an environmental engineer. It's really any person. It's a way to kind of model your education. So then what do environmental engineers actually do? So environmental engineers do three things, with one and two being the kind of historical or the sort of the history. So environmental engineers used to be called sanitary engineers. I think environmental engineering probably is a more marketable term. Sanitary engineering, I don't think gets that same enthusiasm, but the reason we were called sanitary engineers is because the main thing we were doing was protecting public health. We were, cleaning water supplies so that water was safe to drink. We were also, and by cleaning it, I mean, designing systems, designing processes to do that. And then we were also designing processes to protect the environment. And so water is one of the best examples of this, where we take water from the environment, like lakes and rivers, and we put it through a series of processes to make it clean and safe for humans to use. We use that water at home for many purposes or in buildings, and it then gets polluted. It has human waste in it and chemical waste. And then we actually send that water back out into the environment. And in the past, unfortunately, you could kind of envision a sort of very harmful circle that occurred, which would be if people, when society wasn't sort of knowledgeable about this, right, they polluted water, they sent that polluted water right back into their water supply and took it out and used it, and then people got cholera and other sort of waterborne disease outbreaks. So we recognized that some separation between the water we used and the water we wasted was necessary, but that then putting sort of engineered controls on both engineered processes at a water plant, engineered processes at a wastewater plant. And so all of what I've said so far was really about protecting human health. But the other thing is to think about the ecosystems involved. And so when you send untreated wastewater out into the environment, it sort of obviously pollutes the environment. But one of the key things it does in terms of water quality is that it depletes the oxygen in lakes and rivers, because all this organic material that you release breaks down, depletes the oxygen, and then all the organisms, the fish in particular that live in the water, die because there's no longer any oxygen there. And so you get these huge fish kills. And then if you've ever had, probably see this in high school biology, the various food webs. And so when you make one major disruption to a food web, all the other sort of species, both higher and lower, are connected. And so it has a huge cascading impact. And so we recognized then that we needed to design these wastewater plants not only to protect human health, but also to protect ecosystems. So those are the two main roles of environmental engineers: protect human health and protect ecosystems from humans. But then there's a third role, which is to restore and improve ecosystems. We haven't always done item number 2. And so since we haven't done item number 2, that therefore creates item number 3. There's a lot of legacy pollution sites, where former manufacturing facilities were, or industrial facilities that, for a variety of, either unintentional or intentional reasons, really left behind a legacy of pollution. And so what environmental engineers will go do, and these are the worst of the worst sites, are referred to as Superfund sites, which is a sort of federal designation and sort of a regulatory system of cleaning them up. And there are, unfortunately, some of those sites in Phoenix. So what an environmental engineer would do is would first go assess the site, determine, what type of contaminants there, the range of contaminants, and then come up with a plan to clean up that site. And that plan has both, a technical component, it has a legal component, and it also has an economic component. What is it going to cost to do that? And so a few other comments, these are some notes I've had to make sure I comment on. So I've said how sort of 1 and 2 are the sort of history of being a sanitary engineer, and number 3 sort of comes out of not doing number 2. Sanitary engineering also came out of civil engineering. So civil engineers are sort of historically associated with doing big infrastructure projects, roads and bridges and other, infrastructure for cities and states. And so environmental engineering in the past, or sanitary engineering in the past, was sort of a sub-discipline of civil engineering. But really, with the sort of scope of problems out there now, environmental engineering is its own discipline. It's its own degree. It has its own professional societies. And the way I think about it is that a lot of civil engineering is very much physics-based. And so what I mean by that is civil engineers design structures like bridges. They also do what's called geotechnical engineering, which makes sure that the sort of the ground can support structures, transportation engineering, materials. So a lot of that is really based on physics, balancing forces. Environmental engineers do rely on that because, for example, physics is what sort of dictates water flow. And that's important for us. However, what we really do is, take that sort of physical system, like water flow, and design engineering processes around chemistry and microbiology. And what we really try to do is manipulate chemical and microbiological processes into engineered processes to achieve a goal. Achieve a goal of taking lake water and making it drinkable, achieve a goal of taking, wastewater and turning it into some sort of safe water. It turns out that chemical engineers actually do a lot of those same things, but they do it in a sort of well-defined, industrial setting. So they take, some chemicals in and will make peanut butter, right? Or they'll make oil, or they'll make some other all the range of commercial products. So environmental engineering is kind of situated in this interesting position of sort of, kind of evolving from civil engineering and kind of sharing some of the physics aspects, really relying on a lot of the same fundamental concepts of chemical engineering, but in general focused on a very different set of problems. We're focused on those sort of problems that are out in the world and out in society, whereas chemical engineering is much more focused sort of internally on sort of industrial and commercial processes. So a few more things about human health. I reference water a lot because that's the type of research I do. But air quality and air pollution is also a very important part of human health that environmental engineers work on. So with water, we'll monitor water quality. We'll come up with new technologies to clean water. Some of the same things on the air pollution side. A lot of work needs to be done, or where work typically starts is monitoring. Where are the pollutants? What are the pollutants? Once those things have been established, then we can sort of design or implement different control technologies. And so there's a lot of parallels between water and air. Where you do that, a major employer would be engineering consulting firms. So these are private companies that do the engineering design work. If you work with within a city or a state department, you'll probably be associated more with maybe the monitoring or the compliance or the permitting, not so much on the design side. And then private companies, you would possibly be doing the design or the monitoring. It really depends on your role within that private company. Are you more associated with sort of making sure that private company doesn't pollute? Or are you helping that private company maybe design new processes? Protect ecosystems from human activities. Examples in water would be wastewater treatment. Solid and hazardous waste management is another example where we have different systems in place to dispose of solid waste through landfills or incinerators, to recycle, to recover valuable resources. All of those things, we're really trying to prevent our human activities from impacting the environment. And then restore and improve the environment. This is a kind of a cartoon of a contaminated site. Over on the left, we see a kid, unfortunately, playing in like a puddle of hazardous chemicals. We see some chemicals were buried below ground and they're now leaking. These chemicals can get into groundwater that then could, say, enter our homes. And so this illustration on the left is what we would, as an engineer, we would go assess that site, figure out, where is the contamination? Is it just in the soil? Is it in the water? What is the chemical? And then we would figure out how to remediate it. And this is very much in the sort of engineering consulting domain where, a city or a private company, realizes they have this contaminated site, and then they hire an engineering consulting firm to remediate it. This is another way to think about the sort of careers in environmental engineering. So we've talked about the big challenges facing society. We've talked about what kind of person is needed. We've now reviewed sort of what an environmental engineer does. And hopefully you see the linkages, right? I mean, challenges were things like sustainably supplying food, energy, and water. And what we can see is that environmental engineers very much work with water. And by having clean water, that can allow us to grow food and, interact with energy generation. This is another way to think about what environmental engineers do. So those, the main branches of the tree are the sort of main areas where environmental engineers work, and water and air and energy. And then the sub branches, or, the smaller branches, are kind of specific kind of niche areas where you could have a career. And you know, a lot of these main parts of the branch would be sort of areas within an environmental engineering consulting firm. Like some firms specialize in just water. And so you would work with a firm that specializes in water, and then throughout your career, you might do drinking water treatment or stormwater or groundwater. Or you might work in a firm that's broader that does, say, water and wastewater design. Or you might be interested in other parts of the environment, you know, maybe the solid waste management there on the far right of how do we get the most out of the things that we kind of want to throw away? Are they really waste, or can they be, you know, so recycling is kind of what we do now, but can we extract the sort of valuable materials that are sometimes kind of hidden in our waste? And then in the middle here, we have things like air and energy and risk, which are also important parts of environmental engineering. And again, these activities are mostly done through engineering consulting, where you're a design engineer. However, you could be employed with various city government, state agencies, where you're probably more closer to the sort of monitoring side or, you know, permitting. And then you could have different roles within private companies. Many private companies, you know, Intel, ExxonMobil, et cetera, employ environmental engineers. Sometimes they employ them to help them pollute less. Sometimes they employ them to help them with, you know, pollution problems of the past. Sometimes they employ them to help them sort of design new technologies. So really a range of options available to you. And finally, just a little note, just kind of deals with that breadth of knowledge, which is federal environmental acts have a major impact on what we do as environmental engineers. The sort of history of environmental engineering comes a lot out of the fact that we've created environmental regulations, and that then required, you know, city and states to do something, and that do something means they hire a consulting firm. And so the sort of do something that needs to happen next is this. There's a group of chemicals called PFAS, per and polyfluoroalkyl substances. The two most common ones are PFOS and PFOA. If you Google those, you can find stories in the Arizona Republic or wherever you're from. I am certain that you can find a story about these in the last 3 to 6 months in your local newspaper. Almost everywhere across the US, there's a town that has, you know, a groundwater well contaminated with these chemicals. These chemicals are used for a wide variety of purposes, a lot of it associated with airports and military bases and fire training. So that's a concern because they show up everywhere, and now we're trying to come up with sort of ways to remove these from water. But this is going to likely, so the public is very concerned, so that has people interested, and the federal government is likely to regulate these, and that's going to create even more sort of kind of research and work that needs to be done. So it's this cycle of, you know, when the federal government regulates something, that creates even more sort of initiative for us to do things as an environmental engineer. So with that, I'm happy to answer questions on a range of topics. You know, we talked about the challenges facing society, the type of person needed to address those challenges, you know, what environmental engineers do sort of now and into the future. So thanks for attending. Happy to answer your questions.
Thank you, Dr. Boyer. So if you have any questions, feel free to type them in the Q&A. It's definitely a treat to have faculty with us to answer those questions specifically. If you have any questions about the research that's being done by the students during their coursework, you can also ask that, or, you know, some of the, you know, projects that students have done. It's always interesting to know what you're in for. Do you have any questions? I'm also dropping a couple of links. Oh, we do have one. I'm dropping a couple links in the chat for you to reference later on. What kind of internships might be available in environmental engineering in college?
Yeah, that's a great question. So a couple of things related to that question. So first, the environmental engineering major at ASU actually requires that you do an internship. And so if you were to look at the major map that's placed between your junior and senior year. And so it's a course that, so you register for a credit, but the internship is wide open in terms of what you do. And so what students have done, I can tell you, is Some of them have worked for engineering consulting firms, and so there's a wide range of companies. One of them I can tell you could look up is called Geosyntec, but there's many firms. So these firms, some of them specialize very narrowly, as I said, in water or wastewater. Some are very broad. So students have done internships with consulting firms. Students have done internships with city departments and state governments. So, for example, City of Tempe, City of Phoenix, Arizona Department of Environmental Quality. Students have worked with private companies. So, for example, Intel, Freeport-McMoRan is a mining company. Students have also done, in terms of the internship, I also allow students to do research. And so students have gone to other universities for the summer and done research projects and participate in research projects at ASU. So it really spans the careers I mentioned of engineering consulting, city and state government and agencies, private companies, and research.
Thank you. We have a question about classes too. What type of mathematics are needed for the first years? It's from someone who's already been accepted into the major and just wants to be prepared.
Yeah. So typically, I mean, so in terms of the full suite of math, environmental engineering, like most engineering majors, requires up to you to do up to differential equations. And so that means, calculus 1, calculus 2, calculus 3, differential equations, and then linear algebra. And so, there's some kind of flexibility in how you do that, but I think, many students would probably start, in the fall semester with calculus 1, move on to calculus 2 in the spring, and then, use their second year to complete, calc 3, differential equations, and linear algebra.
So I'm dropping a link to the major map for the degree. Well, also congratulations on your acceptance. We're excited for you. So you can see term by term what classes are prescribed for you to take. It also has notes on extracurricular things that you can do, such as starting a handshake profile, which is our career center resource. That way you can see internships that are available, workshops, networking sessions, and so on. Dr. Boyer also mentioned internships. So usually that's done the summer of your junior year. So, and those types of experiences have actually yielded really great results for our students who are trying to find employment, because some of them end up getting employed in the same place where they interned. And it really exposes you to the industry. What are some projects students have done so far? I love this question.
Yeah, and actually, somehow we missed Leo's as well.
Oh, yes. Are there global study or travel at ASU that work for environmental engineering? So you pick Dr. Boyer, which one?
Yeah, so I think with the, so for example, kind of with the study abroad, I mean, there are environmental engineering students who have done study abroad. Study abroad can be a little trickier with engineering in general, just in terms of kind of mapping out, what courses do you take at ASU, what courses do you take elsewhere. But I know students who have done that successfully, so that just requires a bit more planning, sort of early on with your advisor. ASU has great advising, like within each sort of college, within each school. We're called schools. There's dedicated advising staff that can help you. So global sort of study abroad options are possible. And then, in terms of projects, there's a couple ways to answer that. So, in a lot of, not a lot, but, in various junior and senior courses, there's typically a project, like a semester long project. And so, I teach a junior course, and I co-teach that with a practicing engineer. And so he's actually taking sort of previous projects from his firm, and then the students kind of rework those projects. And so since he's based here in Phoenix, he's taken sort of, super fun contaminated sites that his company has cleaned up in Phoenix. He sort of removed the exact location, and students have sort of redone that design. Given this contaminated site, what would you do? In terms of research, so in terms of coursework, it's kind of set up like that often. Here's here's a contaminated site, or design a city of the future. In terms of research, though, it's wide open. So if one were to do, say, research for the internship credit, which is possible, then you're kind of paired up with an individual faculty member, and you might do something related to, a new advanced drinking water treatment technology, looking at nanotechnology for water treatment, or biotechnology for wastewater treatment. It could be, I'm trying to think of what some other faculty members do. I mean, some of them do more kind of computational and computer-based research in terms of, collecting data from different sources like air quality monitoring stations and trying to figure out, have new, like, for example, there was some work done of like, how did air pollution change from, the coronavirus, right? When people were driving to work less, or, driving to school less. So studies like that. So I guess to kind of recap, in terms of research, it's, advanced water treatment and wastewater treatment, air pollution monitoring. There's some work, related to, students who work with me do projects that are more related to like recovering valuable materials from wastewater. So there's actually a lot of value, sort of hidden materials that we can recover. So it's really pretty exciting in terms of how wide open the projects can be.
Before we move on to the next question, in terms of research, I also want to mention that there are plenty of opportunities for undergraduates to engage in research projects. So you don't have to be an upper level junior, senior, or graduate student to engage in research. A Fulton Undergraduate Research Initiative is something that you can do. So you get a faculty mentor. Sometimes you also have an industry or community partner in that. You receive a stipend of $1,500 per semester to conduct your research, and you also get $400 towards materials and resources for your research. So that's a great way to really expand your knowledge and your breadth and depth, as Dr. Boyer was talking about. We also have, there's a course, a credit course called Engineering Projects and Community Service, EPICS. And I've seen a lot of environmental engineering type of projects go through that. We have a recruitment assistant in the office who has been working with the Tempe water facility for a couple of semesters now, trying to work with them on improving processes and similar things. So that's, again, being partnered with a community organization so that you can really see your results impact the community around you. Question for the 4+1 program: do you have to decide to do that program right away or later? I can answer that one. You actually apply in your junior year, so you do have time to think about it. And also Fulton Schools of Engineering offers cross programs. So you might decide to get your undergraduate degree in environmental engineering and get a master's degree in something else. So that's okay. And the way it works is after you're accepted in your junior year, in your senior year, you take classes that count towards your bachelor's degree and your master's degree. So you graduate with your bachelor's degree, and then you come back just for one more year to get your master's degree. You do have time to decide.
Yeah, but it's a great program. Is very efficient in terms of in 5 years getting your bachelor's degree and your master's degree.
These are great questions. Any others? I also dropped a link to our study abroad programs. We have our own, Fulton Schools of Engineering has its own study abroad office. So they're really customize the experience to your engineering and technology majors. Right now, there's not a lot going on with travel restrictions, but they are still offering events and opportunities, mostly virtually, but that is available. And also, I dropped the site for the environmental engineering department for the major. I'm sorry. So if you haven't had a chance to look at that yet, there's a lot of really helpful information such as career outcomes, the major map, a link to the major map, admission requirements, and so on. For those of you who are interested in research, there's a section about research as well. Yeah, so we do have a lot of information there. Also, if you are interested in chatting with a current student who is in the environmental engineering major, we are taking one-on-one virtual meetings. We have a group called Fulton Ambassadors. They are a leadership group within Fulton Schools of Engineering. They help prospective students, guide them through their application process. They're really great. They give a wealth of information about their experience as students. We also have some recorded lab tours on our website that the Fulton ambassadors have done. But yeah, if you're interested in speaking to someone one-on-one and asking more specific questions about the student perspective, you can do that on our website as well. You can request a visit with them or with anyone on our staff, really. Are there any other questions? Dr. Boyer, do you have anything to add? Any final thoughts?
No, I was happy to have a chance to meet with you. I think they're great questions. Feel free to reach out to me. I think you find that, most faculty are happy to talk to prospective students, tell them a little bit more about the major. So, don't hesitate to reach out to someone like me or someone else in another major.
Okay, well, if you don't have any other questions, we hope this was really helpful for you. We hope to see you at ASU. You are welcome to sign off, but we're going to stick around just in case, just until the last person leaves, just in case there are any other questions.